In this video, we're going to be looking at one more way of approximating the area under a graph. So, I'm interested in finding the area under 3 minus square root of x between 0 and 4, looking at n equals 4 subintervals. So, again, I've got these nice even subdivisions. My delta x would be 4 minus 0 over 4, which is just going to be 1. So, left-right Riemann sums, midpoint sums, we all use rectangles to approximate our area. This time I'm going to use a slightly different shape. So here at x sub 0, I'm going to trace up to the y value of my graph. Over at x sub 1, my y value is down here. If I draw it in a straight line like that, and then connect that back down, I've got that quadrilateral right there. I can do that for my second interval. Connect those 2 points. Make a shape like that. Keep on going. Connect that pair of points. Looks like that. And connect that pair of points right there. So I'm going to be using these shapes to approximate my area. So eyeing these rectangles we had a nice formula for. These are more unusual shapes. We've got this word trapezoid hanging out over here. So if you think back to elementary school geometry, you may have learned the formula for the area of a trapezoid. So I've got my trapezoid here like this. I'd look at my height, that would be like measured down to a right angle with both bases. And so we've got my base sub 1, b sub 2. If I find these 3 lengths, my area is going to be 1/2 b1 plus b2 times h. This over here is a nice isosceles looking trapezoid. We've got trapezoids though in other forms. We could kind of maybe shrink and expand either of these. If we happen to have a trapezoid that maybe looks a little bit like this, we've got 2 parallel sides, quadrilateral, that's all we ask. Things meeting at a right angle here. This would be our height. This would be our b1, b2. That would give us the same formula. And maybe this looks like a shape whose area we want to calculate. So, let's go ahead and do that. So if I look back over to my graph right here, I need to calculate the areas of all of these trapezoids. I'm just going to do the first one here in the video, a sub 1, area of my first rectangle, or not rectangle, trapezoid. It would be 1/2 times my 1 base. I'm going to look at this whole length that's given by f of 0. That would have been my y value up here. So f of 0, I've got 1 right here, that would be my other base. And then my height right here, that would have been my delta x. I can keep on doing this for all of the other areas. I'm going to skip ahead and write out my whole area formula. So I've got that my area is going to be equal to, 1/2 f of 0, 3 minus square root of 0, plus f of 1, 3 minus square root of 1, all of that times my delta x, which is just 1. So that's that first area. Second area, that's going to look like 1/2. So this is going to be f of 1, this length right here. So I'll have 3 minus square root of 1. My other base, that's going to be f of 2. 3 minus square root of 2. That times delta x. Keep on going. Third trapezoid, 1/2 3 minus square root of 2 plus 3 minus square root of 3. And then last one, 1/2 times 3 minus square root of 3 plus 3 minus square root of 4 still times my delta x. Add all of those together, lots of calculator work, but I'm going to get to an answer of 6.853736-ish. So that's my approximation of my area. If you watched the midpoint sum video, we're in the ballpark more or less of that value, so that's at least reassuring. For the rest of this video, I'm going to look a little bit at how we can shortcut this whole sum, because those are a lot of terms to write out. So, if we head on over here. So, I'm interested in figuring out midpoint sums. I'm going to draw myself an interval, trapezoid sums, a to b, and as usual we've subdivided. This was my x sub 0, x sub 1. Keep on going, we've got my x sub n minus 1 here, and b is x sub n. And then we've got our various trapezoids here, so like if I were to have maybe had a trapezoid like this, and then maybe one like this, and then sort of levels off. So we're computing our trapezoid sum. As I said before, that would have looked like, in full form, my trapezoid sum with n. Subintervals would have been 1/2 f of x sub 0 plus f of x sub 1. Those would have given me my two bases right here, and then multiply that by delta x. Then I've got another term, 1/2 f of x sub 1 plus f of x sub 2 times delta x. 1/2 f of x sub 2 plus f of x sub 3 delta x. Keep on going. And my last term is going to look like 1/2 of f of x sub n minus 1 plus f of x sub n. Multiply that by delta x, and that's my area, or at least my approximation. I want to shortcut this. For one thing, I've got this 1/2 in every single term. I can factor that out, at least not have to write it down over and over again. Same with this delta x at the end, that's showing up everywhere. Might as well just multiply by it at the end, as long as you remember. And now, if we look at what happens in the middle, we would have had this plus this plus this plus this, etc. Can add those all together now. So I've got my f of x sub 0. Add f of x sub 1, but I've got an f of x sub 1 over here as well. I can combine those two. Now I've got my f of x sub 2, but I've got my f of x sub 2 showing up again over here. My f of x sub 3 would have also shown up twice here in this next term that I didn't write down. Keep on going. F of x sub n minus 1, that would have shown up in the term just previous, so I'm still going to have two copies of f of x sub n minus 1. But f of x sub n, that's only going to show up, so I've only got one copy of that. So this is what my sum looks like. I guess if I want to use sigma notation, I could say we've got 1/2 times, f of x sub 0 is on its own. We've got two copies of all the rest of the stuff, so we would have 2 times the sum. And it looks like we're starting at f of x sub 1, so I equals 1. We end at n minus 1. That would be f of x sub I. And then we still need to add on our last f of x sub n, and then better match my parentheses, multiply by delta x at the end. So you could think of this as your Riemann sum formula. Personally, I find it easier just to remember that we're multiplying all the middle terms by 2, add on the 2 far left and right endpoints, and then multiply by 1/2 and by delta x at the end. Thank you.